morning. I'd like to present to you
The biotechnology class at Salt Lake Community College has prepared me to work in many aspects of the business.
Students gain experience in a real GMP biomanufacturing environment.
This is the high-speed tip.
At Salt Lake Community College, in a program called STUDENTfacturED, students create, manufacture, market, and sell biotech products.
We have products on an online website.
I will go back to the website if I need any more.
Okay.
This contract manufacturing organization prepares them to be productive, efficient workers for the biotech industry.
It's a different mindset trying to produce a product for customers, so it's kind of given me the business and the science experience at the same time.
We have a strong potential market.
Today, students design and develop ways to improve the lab kit they sell to high school biology teachers.
We just came to deliver your order.
Validation, right?
We have 3 students who are just transitioning into STUDENTfacturED.
Okay, get your other one.
We have Lance, Becca, and Jem coming in to a whole new world.
So yeah, this is just one order.
Celie and Brandon are mentors here who are able to help the interns to keep them on the right track.
Gonna run 1%.
Our mentors are currently developing a DNA ladder product.
I have my project that I'm working on. I'll also be helping with the plasmid project that we're working on.
It's definitely cool to start something new, like the plasmid project. Having us create a real product, that to me just sounds like it's a big responsibility. We better make sure this thing works. Otherwise, it's gonna look really bad. We don't want contamination. I started school trying to be focused on nursing. I'm not very fond of body fluids or things like that. So I'm like, okay, I need something else. Don't do this, because I have 2 more to cut.
Celie likes to take on a lot of work. When she comes into a manufacturing environment and she comes up with some really good ideas,
And just put QC.
her challenge would be learning how to let others do things as well.
We had to weigh that out. STUDENTfacturED is giving me an opportunity to kind of manage my own project and develop the product. After that, I get to help on writing a business plan for it and trying to market it. And through this, we can lower the cost.
Brandon is very business and marketing oriented, and I think that he could really challenge himself to do the bench work and really get confident in his lab work. I want to see him take charge this semester for sure.
Yeah,
It's a little over a mil. And
Becca's not exactly sure what she wants to do after this. I think she's just sort of feeling it out. She may learn that she absolutely doesn't like this environment and she doesn't want to work in a biomanufacturing company, and she may realize, well, this isn't for me.
I'll run a restriction enzyme digest on it, similar to that of which we do with our quality control.
Lance wants to own a pharmaceutical company. I hope that Lance really pays attention to the regulations involved, because owning a pharmaceutical company is not going to be a small task, and he'll have to learn exactly how big that's going to be.
if we were doing,
I see with Jem, she's very talkative, which can be great.
I think these are just different.
She's really great at the hands-on work. I think that sometimes she doesn't always think about the bigger picture.
One of the things that helped us differentiate was P-Glow. It might be a little bit easier for some people to comprehend. I like sharing my ideas. I like coming up with my ideas, and I like to put them into action.
The pecan didn't grow on it because it's only resistant to kanamycin.
I like that there's a lot of responsibility on the students, because if you're just given kind of like, here's what you need to do and this is how you do it, I don't think you really learn anything.
And do we need a gene inserted, or are we not going that far in the
Good
experiment?
question. Do we want to have one?
I think it would probably depend on the bounds that they want to test the students. In other lab classes, it's a preset experiment. In this class, there is no determined outcome. I'm going to remember it better, and I'm going to understand the concept and be able to apply it in different ways than I would if I just learned it in a book.
Really, the first step is research and development. Make sure that we have a plan that, at least on paper, looks like it's going to work. So the product that we have is based on the unknown plasmid lab for our high schools, where you have the 3 plasmids, but we don't know what ones they are. So this goes over the kit. The challenge that we have is this design team is we're going to be figuring out what we would like those plasmids to look like. So think about what things you have to have in a plasmid. We want to make our plasmids all the same size, but we also want to incorporate some unique features in them. Our students get a hands-on experience actually making a product based upon the skills that they've learned in the research. First thing we need is restriction sites, okay?
Origin of replication.
Origin of replication, that's a big one.
Antibiotic resistant.
That's a selection, right? We need a selection method. They're going to be involved in the research. They're going to be involved in developing these things. They're going to have to figure out how do we actually measure a quality metric for this product. They're going to need to figure out what the testing is. They're going to need to figure out what the testing needs to validate. They're going to need to figure out how do we package it? What does this thing look like when we send it out?
They appreciate it and they'll have to prove their skills. Yeah.
So my expectations are really at the expectations I would have if I were a company and just hired them as a development team. Seeley, remind everybody else what the multi-cloning site is.
The part of the plasmid where you can insert other genes to it. You're gonna have to plan your whole project. Like, where do you start from? What is that you have to do? What do you need to have those things done?
Okay, they stuck it inside.
They actually have to take charge and say, well, I have to really think about this. I have to really problem solve. I have to prioritize. I have to manage my time, all of these things that you really need when you start working at a real company, when you go into industry.
We need to do production, right? We need to see if it'll actually work.
We don't need to do quality assurance because if it's one shifted by one nucleotide, it can mess up all of our genes and then we're sending them a product that doesn't work.
Quality, right? We've got to make sure everything works.
Definitely.
Yeah.
Quality is a step that a lot of people overlook, especially when we're students. As long as we can get the answer and the teacher gives us a decent grade, that's about all we care about. We're making something now. We have a name, we have a reputation, we are an organization.
The tasks have become much more clear. Now we know we need to pay attention to determining the user needs and how we're going to implement those into our design process.
How are we going to market, advertise it?
Yep, so market research. Now, we have a starting market.
I think even too, we could do a training for like biotech companies. Make it part of the training phase. If you come out with a really great idea, you need to be able to sell that product, make it marketable. That way you can pay off the debts you've accumulated from research.
So we need to have some way that the customers can feed back to us about any challenges they may have had.
In the medical device company, it's customer feedback, anticipating risks, and mitigating them.
Having the know-how to get the marketing out there and also how to design the product so that people will want to buy it and they understand why your product's superior is just as important as the research.
There's an approach called the waterfall design, and this is what the FDA uses in medical device design. We establish our user needs. If we can expose the students to FDA regulation whenever possible, that will help them get familiar with the process so that when they do get to a real job, they've seen this before, they understand what it is. We figured out what our design kind of needs to look like. Once we have that, we go into what's called design process. And then we have our design output. It's our product, right?
The biggest challenge, I think, is going to be validating everything, because it's easy to put a bunch of ideas on paper, but to make sure they actually work, it's going to be the hard part.
We need to validate that our design is correct. We also will validate it with our customers. If it meets their needs, we'll keep making it. And then review, and you do that at every step along the way. That's it.
The next step is coming up with a protocol, like for how we would run the lab.
I'm going to be challenged a great deal, so I'm a little bit worried about that. The truth is, I'm a little bit intimidated.